Okay, so our last lesson was solving nonlinear systems of equations, and we're going to do something brand new. I assume it's brand new to you. We're going to look at 3 variable systems of equations. So we're not only going to have x and y, we're also going to have z. So those are 3 variables. You cannot solve this by graphing. You have to know how to do it algebraically, unless you have like a TI-89 calculator, but Desmos is not sophisticated enough to graph it, and TI-84s are not sophisticated enough. Our learning target is I can solve 3 variable systems of equations. So here's your important things to know. The solution to a system of equations with 3 variables is the ordered triple xyz that satisfies all equations. So normally we looked at xy coordinates, now we're going to look at xyz coordinates. And yes, that is a thing in math. And no, you're probably never going to use it, but it's a thing. So if you do become a math major and you go far in life, now you know. 3 variable systems of equations can have 1 solution, no solution, or infinitely many solutions. So that's a little bit different than what we did on our previous lesson. And then to solve a system with 3 variables, number 1, we're going to eliminate a variable from a pair of equations, then eliminate the same variable from another pair of equations. I'll show you what I mean. Number 2, we're going to solve the resulting system of equations from step 1. And 3, we're going to use substitution to find the value of the 3rd variable. So we already looked at substitution in the last video, but what you may not remember is elimination. And that is from Math 1. So we're going to review that and put this all together. It gets a little tricky. It's kind of difficult, but just follow along and then ask me if you have any questions. Alright, so here's our system of equations. We have 3 equations. We have 3 variables. It looks really yucky. Okay, so what I'm going to do is I'm only going to work with 2 equations at a time. So I don't know if you can tell, but do you see how the 2z and you have a negative 2z? And if you were to add those equations together, the z's would cancel out. So that's going to be our end goal. We're going to make the z's cancel out. Okay, so maybe you remember this from Math 1, but I'm going to add these 2 equations together because if I do so, the z variable is going to cancel out. So watch what happens. X plus 5x is 6x. 3y plus 2y is 5y. 2z minus 2z cancels out. Equals negative 13 plus negative 11 is negative 24. So already I've made this go from a 3 variable equation to a 2 variable equation, which is a lot easier to deal with. Okay, now what I'm going to do is I'm going to take 2 other equations, and it really doesn't matter how you pair them up. But I'm going to take those 2, and I'm going to do some elimination with them, and I'm going to try to eliminate the same z variable. Okay, so the 2 in blue, if they were like the 2 in orange, I could just add them together, but they're not. But if I had a positive 2 in front of that z, the second z, then I could get rid of them. So think, what would I have to multiply negative 1 by to get a positive 2? The only thing that would work is to multiply everything by negative 2. So here's what I'm going to do. I'm going to write this equation over here, and I'm going to distribute that negative to everything in that second equation. So I have negative 14x plus 8y plus 2z equals 58. Oh, negative 58, my bad. So now, if I add them together, the same thing's going to happen to those first 2 equations that we did in orange. So 5x minus 14x is negative 9x. 2y plus 8y is 10y. These z's are going to cancel out, and it's going to equal negative 69. So notice, in the orange equation, I got rid of z. In the blue equation, I got rid of z. I picked the same variable to get rid of. So now what I'm going to do is I'm going to take these 2 equations, and I'm going to solve them. Okay. So I'm looking at the 2 in green now. and I'm trying to solve them like I would have in Math 1 with elimination. So I think the easiest thing to do is to try to get rid of the y's. So the second one has a 10y, positive 10. I'm going to make the first one cancel out. So in order to get a 10y to cancel out, I would need a negative 10y. What would you multiply positive 5 by to get negative 10? Negative 2. So I'm gonna multiply everything by negative 2. And now I'm going to add the equations together, and the y variable is going to cancel out. So I have negative 21x, these cancel out, equals negative 21. And to get x by itself, I would divide by negative 21 on both sides. So x equals 1. So now I have one of my answers. And I can start taking that variable and plugging it back in. So, like if I know x equals positive 1, I'm going to plug it in right there. So I got negative 9 plus 10y equals negative 69. I'm going to add 9 to both sides. 10y, oh, this is getting really ugly, sorry. Equals, let's see, negative 60, and then I'm going to divide both sides by 10, so I get y equals negative 6. So now I have two answers, and I'm going to use these to plug them into really anything I can find. So I'm just going to use that very last equation, the original right here. Alright, so I know that x is really 1. I know that y is really negative 6, and I'm trying to figure out what z is. So I got 7 plus 24 minus z equals 29. Alright, this becomes 31. I'm going to subtract 31 from both sides. And I'm going to divide both sides by negative 1. So z equals positive 2. So here's my final answer. I had x was 1, I had y was negative 6, and I had z was positive 2. There is my answer. That is a big, long, drawn-out process. It is not fun, but that is what you do each and every time. Okay, so I'm going to show you how to do this next one, and then I'm going to let you try the other ones and give you the answers to them. Okay, so first thing, we need to figure out what variable can we eliminate first. So I think what I'm going to do is I'm going to get these two equations together. So I'm going to rewrite them. So I think what I'm going to do is try to get the x's to cancel out. So in order for the x's to cancel out, if the first one is a 3x, the next one would have to be a negative 3x. So I'm going to multiply everything by 3. Alright, and now I'm going to add the two equations together. And now I'm going to get y by itself. No, I'm not. I jumped ahead of myself, sorry. So now I'm going to pick two more equations to look at, and I'm going to try to get rid of the same variable. So my goal for picking these next two equations is to get rid of the x variable also. I'm going to do the first one and the last one. Alright, so I want the x's to cancel out. If I had a negative 4 in that second one, then I can get them to cancel out. So the only way to make that happen is to multiply everything by 4. Okay, so now I can add the two equations together and I can get the x's to cancel out. Okay, so now I have two equations that only have two variables. And I want to get these to cancel out. So here's what I'm going to do. Let's say I want to get the y's to cancel out. I'm going to multiply this first one by 27, and I'm going to multiply the next one by 17. But I always want one to be positive and one to be negative, so I'm just going to make this one negative 17. So go ahead and distribute those numbers and see what you get. Okay, so if you can't think of what to multiply by, just multiply by, like you had 17 in front, so I'll multiply by 27 because that was in front of the other one. And just make sure one's positive and one's negative. So now I'm going to add my like terms together, and my y's are going to cancel out, which is what I wanted. And now I'm just going to solve for z. Okay, so then if I know that z equals 3, I can use that to plug back into another one. So it's kind of up to you, whatever you want to do it. I'm just going to plug it in. Like, I'm going to take this z right here, and I'm going to plug it in to this equation. So something like that. And now I'm going to solve for it. So I got y is equal to -2. And now I'm just going to take that -2 and I'm going to substitute into just one of the other equations. So I'm going to put it right here. So here's what you end up with. So I'm going to get all my like terms together. And I get x is equal to -8. So I know that's really confusing, but here's my final answer. My x coordinate was -8, my y coordinate was -2, and my z coordinate was 3. So you have to stay really organized. I color-coded stuff. If that helps you, then that's what you do. Okay, so there are some to try on the paper. I'm just going to give you the answer choices. And if you have any particular questions, you can email me, send me a message on Remind, ask me in class, do whatever you need to do. Okay, so go ahead and pause the video and try this one, and then I'm going to write the answer up. 1, 2, 3. Alright, so the answer is -4, -1, and -10. If you have questions, ask me about them. I want you to try this one. Pause the video in 1, 2, 3. Oh, sorry, that's a +3, then a -3, then a -7. If you have questions, ask me about them. Okay, so let's look at the application problems, because that's what people actually do. Okay, so Misha and Ben's combined ACT score was 2,290. Ben and Ashley's combined score was 2,530. Misha and Ashley's combined score was 2,660. So find each student's individual SAT score. So the first thing that we're going to do is we're going to assign some values to it. So we got X, we got Y, and we got Z. If you don't like that, you can use M, B, and A, whatever you want to do. But I'm going to say that X is Misha, because that's the first one I get to. I'm going to say Y is going to represent Ben, and I'm going to say Z is going to represent Ashley. So, if Misha and Ben's combined SAT score is 2,290, it's going like that. If Ben and Ashley combined score 2,530, looks like that. And then if Misha and Ashley have a combined score of 2,660, here is your systems of equations to solve. Okay, so I'm going to let you pause the video and try it, and then I'm going to give you the answer. 1, 2, 3. Alright, so here's what you should get. Misha, which was X, you should get 1,210. Ben, which was Y, you should get 1,080. And Ashley, which was Z, you should get 1,450. Okay, so ask me if you have any questions about how to actually use elimination and do that. Alright, so I want you to see if you can set this one up. So don't go solve it yet. Just see if you can assign values for X, Y, and Z, and then use the wording to come up with a system. So go ahead and pause the video. 1, 2, 3. Okay, so I think this one's pretty hard, but this is what you should get. And that is a minus sign right there, sorry. Okay, so see if that makes sense. If it doesn't, send me a message, ask me for help. And I want you to go ahead and try and solve this in 1, 2, 3. Alright, so here's what you should get. 16 pennies, 5 nickels, and 12 quarters. Alright, This is a super hard lesson, and I'm only teaching it to you because you are in Math 2 Honors. If this were standard class, I wouldn't even bother, but I want you to be aware of how to do it. So go try your assignment. Let me know if you have questions. Good luck. Bye.